Welcome, stargazers. Could you at any point trust it? Picture a divine event so gigantic that it creates shaded areas on Earth, noticeable even without really trying to hide. That is the exhibition we may be near the precarious edge of seeing in the Orion group of stars. The star Betelgeuse is acting bafflingly, alluding to an approaching cosmic explosion blast that will illuminate our sky more than ever. But when will Betelgeuse go supernova, and what will it look like? According to researchers, what mysteries could this heavenly event reveal? Join us as we dive deep into the details of what's actually the deal with Betelgeuse and the effect it could have on Earth and maybe for the whole nearby planetary group. Found roughly 650 light-years from Earth in the constellation Orion, Betelgeuse isn't just any normal star. It's a red supergiant, perhaps one of the most glowing stars known to us, shining with a brilliance more than 100,000 times that of our Sun. But why does this red giant matter to us so much? Well, Betelgeuse stands apart not just for its brilliance, but also for its history and importance in human culture. Named after the Arabic expression Yad al-Za, which means the hand of Orion, Betelgeuse has been noticed and recorded by ancient civilizations for hundreds of years. It has been a guide for voyagers and a mark of wonder for stargazers, with its ruddy shade distinguishing it from other stars in the Orion constellation. Can you imagine a single star predominating our entire solar system? To give some perspective on the sheer monstrosity of Betelgeuse, if it replaced our Sun, its edges would stretch all the way to Jupiter. How can a single star achieve such giant extents? At 10 million years old, it's much younger than our 5-billion-year-old Sun. However, Betelgeuse's gigantic size means it consumes its materials at a much faster speed, forecasting a shorter lifespan than that of other stars. Now, the divine behemoth, traversing a volume large enough to contain more than 1 billion of our suns, is approaching the end of its life cycle. When stars of such magnitude reach their sundown years, they don't simply disappear, they go out with a bang. A supernova blast, beyond human comprehension in terms of energy and brightness, has the potential to eclipse a whole universe, creating shaded areas of brightness across vast, enormous distances. The last time Earth saw a supernova blast this nearby was in 1964, sometime before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way galaxy with the unaided eye. It stayed visible for over 1.5 years, brighter than any other star in the night sky, and even remained visible during the day for several weeks. What secrets do these heavenly leftovers reveal to us? Ancient records from different civilizations, including Chinese and European astronomers, documented the presence of this new star. Interestingly, remnants of this blast, as a growing debris cloud, can still be noticed today, with complex telescopes giving us insights into the violent ends of massive stars. While supernovae have been rare, observers on Earth imagine for a moment a celestial explosion so intense that it rivals the brilliance of a full moon, casting shadows on Earth at night and being visible during the daytime. The radiation from such an event would charge our atmosphere, possibly influencing satellite operations and perhaps even the climate. Betelgeuse, with its erratic dimming patterns, suggests it could be preparing for just such a grand spectacle. Might we be nearly seeing one of the universe's most dramatic events? Recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable change that drew the attention of a solid number of scientists and enthusiasts worldwide. Known as the Great Dimming, the star's brightness, which had been steady for centuries, began to diminish significantly. This abrupt change was so noticeable that even casual stargazers observed it while comparing Betelgeuse to other stars in the Orion constellation. This means that we're not just hundreds of years from seeing its supernova blast, but maybe only a few decades or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness level, leading many to believe that the period of abnormality had finished. In an astonishing turn, the following months saw Betelgeuse's brightness enhanced by an incredible 50%. Such striking variances, while common for variable stars, were surprising for a star like Betelgeuse, which had predominantly shown predictable brightness cycles. The sudden and extreme surge in its brightness pushed the star back into the spotlight, sparking conversations about its immediate future. But what caused the sudden change in brightness? Why did Betelgeuse, one of the most recognizable stars in our night sky, suddenly throw a celestial curveball? Stars are not just shimmering specks in our night sky. They are dynamic entities with life cycles, activities, and mysteries of their own. For some celestial bodies, periodic brightness variations can be expected, much like the rhythms of Earth's seasons. Throughout its celestial lifetime, Betelgeuse has maintained a fairly steady 400-day luminosity cycle. However, with the recent darkening, it appeared to defy its established behavior, testing our perception of the heavenly phenomena above. Now, you may be wondering, are we nearing a heavenly revelation? While the specific reasons for Betelgeuse's inconsistencies are still under investigation, a compelling hypothesis has arisen. This hypothesis, focusing on celestial activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a massive celestial volcano, subtly ejecting and expelling vast amounts of its matter into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a significant amount of its surface material into the universe. This ejection, a great event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to disperse or was pushed away by the force of the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that is far from finished with astonishing US. Many hypothesize that Betelgeuse may be nearing the sunset of its life, a supernova event, a staggering burst of energy that can eclipse an entire universe instantly. This occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much material from a neighboring star, or in Betelgeuse's case, it could be from the depletion of its nuclear fuel, which causes its mass to flow into the core, paving the way for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Stars like Betelgeuse begin their journey by consuming hydrogen in their cores. This initial stage, known as the main sequence phase, lasts millions of years and forms the foundation of a star's life. However, as stars run out of hydrogen, they expand, taking on new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence phase to the helium burning stage marks the star's evolution into a red giant. Over time, as helium continues to be consumed, the star undergoes further expansion and moves into other burning stages, each marked by the fusion of progressively heavier elements. The larger the star, the faster these transitions happen, given the massive gravitational pressures at play. Then comes the climax, when iron begins to form at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced is not enough to oppose the star's crushing gravity. The star inflates in size and creates a collapse, followed by a massive rebound explosion, resulting in the explosive power of a supernova. So, is Betelgeuse near the precarious edge of an unstable end, or is it simply biding its time? Recent research by Japan's Tohoku University suggests that the star may be in its carbon-burning stage right now. Lead scientist Haydock believes that the core could collapse years after its carbon reserves deplete, but not all researchers agree. Contrasting studies from Hungary's Kann Observatory speculate that Betelgeuse is still in its earlier helium-burning phase. The one thing that researchers do agree on, despite these debates, is that Betelgeuse is destined to become the Milky Way's next supernova. Yet nailing down the timing of this event remains an infinite guessing game, with predictions ranging from only a few decades to 100,000 years. Amid these scientific discussions and theories about Betelgeuse's fate, one fact remains uncontested: the very nature of our observations. When we gaze toward the brilliant expanse, there's a subtle curiosity we often overlook. This mystery is rooted in the very nature of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes a tremendous amount of time to reach our eyes. For example, the speed of light, while an astounding 186,282 miles per second still has its limits. As a result, the light from distant stars and galaxies takes time to navigate the immensity of space before it graces our sight. When observing Betelgeuse, you're actually seeing a scene from 650 years ago. What this means is that we're always experiencing the past, not the present, when looking at the heavens. So, even if Betelgeuse undergoes a supernova, the light from that explosion may not reach us for centuries or even millennia. In fact, some have even wondered whether Betelgeuse has already gone supernova, and we're simply waiting for its light to travel, or perhaps, as some scientists predict, we may experience this moment in a far future. So how can we truly see the death of a star like Betelgeuse if we are constantly looking backward in time? This paradox highlights the striking complexity and beauty of our universe. What makes this so remarkable, however, is the way our history will forever be linked with such extraordinary cosmic occurrences. When Betelgeuse does reach the end of its life, we will not only bear witness to the death of a star, but also to a moment in time that takes us back to ancient beginnings when humanity first peered up at the heavens in wonder. And in that moment, we will understand something more profound about our place in the cosmos. As we look toward Betelgeuse's inevitable supernova, it serves as a reminder of the transient nature of the stars that light up our sky. Just as our sun will eventually meet its own end, so too will this brilliant red giant. However, unlike our sun, which will end in a much quieter process, Betelgeuse's explosive finale promises to be a grand spectacle. The energy released in a supernova could be enough to trigger a chain of events that might affect the surrounding cosmos, sending shock waves through space and even influencing nearby stellar bodies. While it's true that such an event could disrupt satellite communications or even produce radiation capable of affecting life on Earth, astronomers agree that the likelihood of Betelgeuse's explosion causing catastrophic consequences for our planet is extremely low. The distance between us and Betelgeuse, 650 light-years, is far enough that even a supernova blast would have only a mild effect on Earth, and likely not in a way that would directly harm life as we know it. However, the knowledge that we could witness a star's explosive death is profound in itself. It is a reminder that the universe is a dynamic, ever-changing place, where even the brightest and most stable of stars are bound by the same natural laws of birth, life, and eventual death. It also serves as a humbling thought. If the supernova happens in our lifetime, we will be able to witness firsthand an event that no human has ever seen before, offering us a glimpse into the power and scale of the universe beyond our wildest imagination. As Betelgeuse continues its unpredictable journey towards supernova, astronomers are keenly monitoring its behavior, trying to decipher clues about its impending fate. The unpredictability of the star's changes adds a layer of mystery to what might otherwise be a predictable event. Although researchers have a general understanding of the mechanisms that cause supernovae, each star behaves differently. The great dimming and subsequent increase in brightness have raised new questions about the conditions surrounding the star's final years. Another fascinating aspect of Betelgeuse's life is the role it plays in our understanding of stellar evolution. As one of the most massive stars in our galaxy, Betelgeuse represents a critical stage in the life cycle of giant stars. Studying its behavior offers valuable insight into how massive stars evolve and die. When these stars collapse in on themselves, the supernova explosion is not just an impressive spectacle, but also a critical process in the formation of new elements. The explosion of a star like Betelgeuse is responsible for dispersing heavier elements like iron, calcium, and oxygen into the cosmos, enriching the interstellar medium. These elements are then incorporated into the formation of new stars, planets, and even life. Without such explosions, the elements necessary for life as we know it would be much less abundant. Furthermore, the study of Betelgeuse's eventual explosion could teach us more about the mechanics of supernovae themselves. The explosion of such a massive star is one of the most powerful forces in the universe, and scientists are still working to fully understand how it unfolds. One of the key questions surrounding the supernova of a red supergiant like Betelgeuse is how the star's outer layers are ejected. In some cases, these outer layers are blasted away in a violent burst, leaving behind a dense core, which may become a neutron star or even collapse into a black hole. Understanding the specifics of how Betelgeuse's outer layers are lost will provide insights into how these massive stars go out in a blaze of glory. The impending supernova also holds the potential to make important contributions to our understanding of neutrinos, which are subatomic particles produced during stellar explosions. In fact, a supernova is one of the few natural events capable of producing large numbers of neutrinos, which are otherwise difficult to detect. The next time a supernova occurs in our cosmic neighborhood, scientists will likely be ready to study the neutrinos it emits. These particles could provide new information about the internal workings of stars and the fundamental forces of nature. Beyond scientific curiosity, the explosion of Betelgeuse will undoubtedly spark awe and wonder. As a visible supernova, it will be a reminder of the impermanence of the universe and the grand cycles of creation and destruction that have been occurring for billions of years. While its eventual demise may not directly impact Earth, the spectacle will serve as a testament to the immense power of the universe, reminding us of the fragile beauty of life on our tiny planet. The night sky, already full of mysteries, will forever bear witness to this dramatic celestial event.